right, so we're gonna do something a little different tonight. We're gonna get into gaming here in a bit, but I've been working on it's like a custom guttering system. Um, I'd love to say I got it from a YouTube video, but I didn't. Um, so I'm like inventing something. I'm basically putting together like I'm basically like waterproofing the underside of my deck, so like that we can be under the deck and the water won't seep through on top of us. So basically, I'm building a roof on the bottom of the deck. That's the plan. So with that, I need somewhere for the water to go. So I'm trying to figure out how gutters work, which is pretty simple. It's gravity, right? But yeah, it's actually a couple trial and errors. I had to undo a day's worth of work. And when I say days worth of work, I got 3 kids, a job. Like it's not that many hours that I had to undo. But uh, everything's coming together pretty good. So what I'm gonna do is I need a bracket. So they don't make this bracket. It's not been invented yet. So I'm gonna invent it. Um, it's gonna be a very specific custom bracket, specifically for my job. No one will ever need this exact bracket. Maybe one similar. I don't know. But I'm not inventing something crazy here. So I'm gonna model it. So if you have been, I know a lot of people in stream during my AMAs have been asking for some more modeling walkthroughs and just kind of see how my brain works. So we're going to, well, basically, I'm going to do it, talk through it, talk out loud, so you guys can kind of see how my brain works or doesn't work like there. But I actually haven't modeled like something. I wouldn't even call this complicated, um, but I haven't modeled in a while. I've made a couple, like literally, I made this the other day. It took me all of 10 seconds. A little stringing action on it, but literally, it's solid. It's ABS, no fill, so it worked out kind of well. So did some 3D printing the other day. Did some ABS on an open frame printer, which apparently you're not allowed to do, but it actually worked just fine for the purposes. So I'm hoping that'll work when I get to the printing stage. So I plan on in this stream is getting this all the way through. I'm going to model, show you guys how I slice it up in my slicer. And then I might even get it started and swing the camera over so you guys can see the 3D printer fire up. But that is the plan. So just do a little inventing. I'm going to invent a part that's not been invented before. Um, should be fairly straightforward, but I'm going to try to model it 100% solid. And I'm going to, hey, Kay, what's up, my guy? Thanks for the sub, dude. Appreciate you. Good to see you. Yeah, so that's the plan for this season. Do a little 3D modeling, take it all the way to 3D printing, hang out with you guys, and then get into some gaming here in a bit. So that is the plan. So you know what? Let's get to it, man. Let's do this. That's where we're going. So hold up. I should have the layout set up for you guys. Boom. There it is. All right. So this gutter. It's actually I couldn't rotate the picture, so tilt your head, whatever. But this little gutter here, um, where my finger is holding it, is actually 90 degrees. So rotate that picture clockwise. But I need this gutter. It should come like straight down, or in the picture it'd be straight this way. I guess this way. Whatever. You know what I'm saying. And I need to attach it to this brown part here, so it's at an angle. And all the brackets that they sell are kind of, I don't know. They're for like flush attachment. So I need to create something that's going to wrap around this part. I actually have that bottom part here. So basically, what's going to happen is this is typically how it would work in a gutter. Is you'd have your downspout come into this, and then the water would come this way. I'm actually going to swing it in, so it's kind of at an angle. So then once we're at this angle, it's not going to be perfectly level because then the water won't drain. So it'll still drain about a ½ inch per foot. But I need something to wrap around this top edge here, and then attach to it's actually the side of the stairs. As you can kind of see, those are stair treads. I don't know why the picture wouldn't rotate. I haven't switched over to slabs yet, and that's probably why it's really hard for me to rotate a picture, which, how is that freaking hard to do? Come on, Twitch Studio, get your stuff together. All right, anyway, I'm going to use onshape.com. It's free for educational uses, and maybe even personal licenses. I'm not sure. But I think, yeah, you can probably get an educational account pretty easily. I'm not selling this part, so I'm not going to break any laws that way. So All right, we're in. So I'm just going to go up, create. First, I'm going to swap these screens so I can see chat, talk to you guys, and I'm going to jump right in here. So you can see some of the parts that I made previously. That was a thing I was going to make for the gutters. I ended up finding a workaround, but just some other simple things that I've made that have been helpful. We'll say the list. What do I want to call this? We're going to call this. Let's call this gutter strap custom. It's a good name for it. So at least that's the plan. But happy Thursday, everybody. I'm a little dehydrated. You're going to see me take lots of drinks. But yeah, hopefully we'll get this thing all the way to manufacturing. And then I'll switch over to do some gaming. Rocket League or Warzone or something. Fortnite. I don't know. I haven't played Fortnite in like a month. All right. So again, I want this to wrap around the top, come out flush at an angle. So I think I'm going to build this from the top down. So let me start a sketch on the top surface. I'll click Start Sketch, click Top. I'm going to orient my view to look at the top and actually come over here and turn off the front and right views. So I'm just looking at this top plane. Now, if you're ever going to custom model something, you're going to need one of these bad boys. You're going to need a dial caliper because you need to be as precise as possible. So I am going to take gutter screws and screw them into this part. But let's just get the exterior dimensions here. So from this, that's what I'm measuring right there. If you don't know how dial caliper works, it's these little jaws. Wrap it around. Reading it takes a little bit of learning. I should have zeroed it first. What a rookie mistake. I was only off by 0.001. No big deal. All right. This measurement is, I don't want to squeeze it too tight, 2.504. So I'm going to create a rectangle. I want to do a corner rectangle. It's a center point rectangle. So starting from the center, just going to drag it out, hit the D key, which stands for dimension, or that button is right here. And I want this. Nope. I want this. Nope. Let's hit escape. Let's try that again. I want this distance. What did I just say it was? 2.50. It's actually 0.45. Be as precise as we possibly can. Stop it, AK. No, you didn't. No way. You were studying hard for that, dude. How did that happen? I thought you were going to go rocket. They don't give you any, like, grace because of the quarantine, because of the virus? All right, let's get I'm going to get this other dimension here. Ugh, should flip this around. All right, I've got 3.216. So this is D 3.216. All right, so that is the maximum diameter there. So I need to be larger than that. So let's go ahead and offset that. There should be an offset tool right here. Yep. Oh, that's weird. I can't offset the whole shape. Interesting. Just bring that out. So this is like the thickness. Let's just stay consistent. They've already got this part, so like I'll just measure its thickness and keep it the same. There's no reason not to, right? At least get close. I'll probably round to something for what they have. So theirs is not even 0.1, 0.075. So I believe you click and then 0.075 to get an offset. Okay, that'll work. Let's see. Actually, I tell you what. Before I want to offset, let's fillet it. So we're gonna curve these edges. Do a little sketch fillet here. I want to do a quarter. See, that's gonna be tough. It's really tough for me to measure that angle. We'll go a quarter round. We can be a little bit loose. I think that'll probably work. Can I duplicate this? Gonna let me? I can hit enter every time. That seems kind of lame. Whatever. I'm sure there's a shortcut I'm missing. That's what I get for not using software that I'm super familiar with. But hey, this one's cloud-based. You need no hardware. I'm literally just rolling. That was your pre-cut class. Ooh, yeah. Patriots fan, what's up, dude? AK, has it been that long since I seen you? Seen you studying for your pre-calc final, but not the calc final? Calc's like a whole new ball game, though. It's like the first time you learn algebra. You're like, whoa, what's happening here? But I get that. Band camp's at 5 a.m. tomorrow, Pats fan? What are we doing? What was this offset number? You guys remember? 0.075, I believe. Yeah, it sounds about right. 0.075. I feel like this should have done. Whoop. I feel like it should have done that the other direction. Why did it not do that? Let's try that one more time. Third time's a charm. What's it doing here? Oh, I gotta flip the arrow. Gotcha. 0.075. Same thing. All right, cool. 0.075. Can I offset the arc? Sure can. So on the software I'm used to doing, it would do these. I wouldn't have to do this manually each time. It would do it automatically. So maybe there's something I am doing wrong to do it all at once. Either way, there's my sketch. Or at least how I want to start. So that gives me around this, give or take. Gives me around this part. About 2 months. Yikes. Okay, we missed you, dude. We were actually talking about you the other day in stream, maybe on Monday or Tuesday. I forget. Did I hear about the band tuba that got COVID? He was at camp, so the future of band camp is that. Oh, like legit, someone in the band got COVID? Like that's a real thing? I thought that was like a dad joke incoming. Which, by the way, I gave you guys a dad joke. You should see there at the bottom. I thought that was a good one. Yeah, but AutoCAD isn't cloud-based yet. And I do mean yet. Apparently it's coming in the form of Fusion 360. It's supposed to be cloud-based coming soon, says Autodesk. I don't know. We'll see. And I'm not sure AutoCAD's better. It's just different. Like I said, I'm quite inexperienced with this program, but the fact that I can fire it up from my phone and I can do all this modeling from my phone through my Android, or I guess if you had an iPhone, you could do it there. You could make that happen. No, real thing. Someone in the band got the COVID. Well, I hope everybody recovers. I mean, they're young people, so they should be okay. COVID has already infected a student. It's going to happen. The question is how bad is it? I don't want anybody to die. That would be awful. All right, so hold on. So I want this to wrap around this front. I'll just show you guys what I'm thinking here. So I want this to wrap around according to that picture that is here. Kind of like this in the picture. Nope, this in the picture. I don't know, it's backwards and upside down backwards for me. I got mirror camera on. So I'm just going to talk myself through this. All right, so this is here. It's going to butt up against it. So I guess I can drop this strap down. All right, so let me just do... no, you know what? I'm going to kill this out here because I don't like that. I actually don't want that to be offset. So I'm going to take a line tool. I'm going to extend this out because that's the part that I'm going to attach it to the... so we're at the beginning of the curve. That might be too thick, but we can fix it. All right, cool. So I'm thinking if I put a hole in here, if I extrude this down and snap a hole in there, I should be able to at least get pretty close to what I'm going for. So let's go ahead and do that. So I hit my finish sketch, that green check mark. Up here should be an extrude button. And why does it want to do the inside? I want to do the outside. Interesting. Is that not a closed loop? What's happening here? None of the entities could... okay, cool. Is it this blue section here? Maybe that's my problem. Let's try this again. All right. If I drop this down, can I hover and then drag out? I sure can. Now, because green or blue, should it be just down? Yeah, AK, totally right. Actually, these guys, the guys that invented this Onshape program, I'm pretty sure worked for SolidWorks before they started Onshape. But I should have this closed figure here, so I should be able to extrude it. Why will it not let me? I want to select this face here, but it's not letting me. So what's wrong with my sketch, boys? Is some of this not closed? Ah, it's not. So I always tell my students, I'm like, dude, if it won't go, you probably have an open loop somewhere, which means I bet all of these are open. No, just one? That's weird. Why would just one of them be? That one's closed. That one's closed. That one's connected. Connected. Why would one of them be off? That's super weird. Maybe they're not. Maybe a bunch of them are off. All right, so here's what we're going to do. We're just going to kill those 3 curves. Probably should have done this the first time. And just use the arc tool. Where's arc in here? Where do they put it? Put it in here? No, I put it right here. Let's go 3-point arc. Here to here. To there. No, that's going to round too much. Oh, I can choose the radius. Okay, cool. All right, so let's do that. 3-point arc from here to here. I don't want it to snap. I need to hit dimension. There you go. 0.025. Is that what the other ones were? Nope. 0.25? Nope. Oh boy, what's happening? That should have been way easier. Oh, I can just. Ooh, I know what I can do. There should be a geometric constraint for concentric. Concentric. This and this. Whoa. What did it just do? It didn't like something. Why can those not be concentric? This arc? That arc. Goodness gracious. Come on, game. Because realistically. There we go. Now it's. So it wants it to be tangent. I guess that works too. 0.325 is the magic number, though. So now that I see that, it'll snap to the tangents. There we go. All right, cool. That was harder than it needed to be. I was looking for a snap earlier. No, I don't know why I didn't snap. There's the snap. And see the little tangent icon that pops up there? There's a little line with a circle. That's how I know those are touching. But yeah, absolutely down to personal preferences, AK. This is not my favorite. I like Inventor for part modeling, which is what I'm doing right now. But AutoCAD's not much difference. Not much difference. Maybe by the same company. So, all right. Now I should have surfaces to extrude, and I do. Aha! All right, so let's see. I don't know. What's a good distance? What do you think here? How big should a strap be, guys? I don't know. Like 0.75? 3/4 of an inch? If we're looking at this piece, the whole thing is roughly 1.25 inches. So this would be half of that. Let's make it an inch. Nah, save material. I like 0.75. I'm gonna print this in ABS. So oof. Yeah. I'm alright. Okay, so the idea is that strap's gonna wrap around this top section here. So, but here's where it gets tricky. So you see that picture below me? It's at an angle, and I already measured it. There's an app you can get on your phone for free. It's like a clinometer or a clinometer, or I think it's clinometer. But I need to get that angle. So what I'm going to do now is I'm actually going to sketch on this front surface, rotate my view around, and I need to. So I'm going to draw a line. Let's go hover and drag. See, I get that dotted line with the hover drag play. So then I'm going to hit close that up. So I want to hit the dimension button and say that from here to here to get this angle. And what I say, 14.5? 13.5. So 13.5. Okay, so if that, because it's going to be at an angle. So you see in that picture, so that's the slope here. That's the degree that's happening here on this gutter. So if we sketch that, and let's extrude this back. Let's add material and let's not make it blind. Let's do to the face. How about this face? Nah, because it's never going to touch that face. Okay, so it doesn't like that. Let's do it blind then. Flip directions. I don't know. I didn't really measure these out to see how far that should be. I mean, that's fine. You know what? Let's go back to the sketch one. So let's do that. It'd be a good way to show you guys. So over here, this is the they call it the feature browser. I'm going to call it the model browser because that's what Autodesk calls it. So if I right click on this sketch one, I can go back and get that original sketch that I edited. And this is just a rookie move here. I probably should have dimensioned this and just given this something. It's close to 1.5. Let's call it 1.5 inches. That's a lot for a tab there. Let's back it off. Let's call it inch. Will save us on print material. All right, cool. And then that auto updated, but the blind did not. So I got to edit this. See, I wish I would, because this plane should extend forever. You know what I can do? I can create a plane. Plane right here, but I don't want an offset at all. So just a 0-inch offset. That created a plane. Plane's going forever, so now I can jump back. I'm going to move that plane so it happened before the extrusion. So now on the extrusion, I can have it go to that face. I should be able to. There. Come on, girl. There she goes. So now she's going to extrude to that face, which that plane is now on that face. So I'll say add material. Cool. I'm actually going to hide that plane by hitting the little vision. All right, cool. So yeah, the reason I did that is now it should, if I'm doing this right, on the back part. Let me blow up that picture for you guys so you guys can see it a little bit better here. Can I share screen? I sure can. Oh, there it's showing right. Yeah, so this strap's gonna go here. You see what I'm saying? So the strap wraps around here, right where my finger's pushing. And then I need this angle here, which is 13.5 degrees. So it should kick out 13.5 degrees, and then it'll end up being flush against the wood. And again, I measured that with literally, I took my phone and downloaded an app and laid my phone on it. So like I'm not doing magic here. So yeah, that should pop out. Now driving the screw, I'm gonna need to be perpendicular to that. So do I want to kick that out? I just, you know what I mean? I want the screw to be a nice solid compression. I don't want the screw to come in at an angle. I mean, I'm gonna put this thing solid, so it's really not gonna matter too much. I'm not gonna over torque it. Oof. What do we think? Yeah, I'm gonna use a flathead panhead screw, or probably a hex head screw. That's flat. All right, let's go back to our model here and kind of look at what we were discussing. All right, so that's the part. Let's kind of, can we? It's kind of the idea here. There we go. So if that's up against the stairs, I want to drive a hole out here. So I really need to kick that out as well, 15 degrees. All right, that's cool. I could do a mirror, but I actually think it'll probably be easier just to create that same sketch. So again, I'm going to grab the line tool, draw a triangle. Now here's the issue right here. People stop all the time. Every time I see like people learning how to model, they're going to they like stop here. And like, look, I got 3 lines. Really, they have 2. So you've got to close that triangle off. I'm gonna hit dimension, make this 13.5. And then the same thing, I'm going to extrude this back to the face. I could probably click on the plane. Why does it not like that face? Two face. I just click on. Let's try that one more time. Extrude this section up to a face. That works just fine. I don't know what I clicked on. I don't really see a problem there. I'm gonna need more material on the tab. What do you mean the tab? Like out here? Oh, you know what I actually need to do? Because how am I gonna get this on here? I mean, I guess I could wedge it on there, but there's no. It doesn't have to hold that much force. It's just holding it in place. Like you're literally picking up wind. That's literally the only force that's going to be applied to it. So check that. What I'm actually going to do here is I am going to. So I'm creating on a top plane here, and I'm going to create a simple rectangle. Let's go down. Yikes, 0.05. Just kind of spitballing here. All right, so I just made this simple little rectangle. I probably could use a rectangle tool for that. I just made that harder than I needed to be. So this little section now, I'm actually going to remove that material. So the reason being now is I'm going to get a little more play. Like this will flex, the plastic will. So I've got a little bit of play with it as I mean, I can still slip it on. I'm looking at this part here. It's thickest up here where I'm attaching it. So I'll actually be able to slip it on here, clamp it, and then when I screw it in, it'll actually clamp down. And even if there's a little gap there, that would be fine. I guess my real question is how thick is this part? I believe the measure tool on this is pretty easy. I believe you just click corner and corner. That'll tell me what screw I need. So that's a 1/2 inch distance. So I'm gonna need like an inch long screw, which is fine to drill. Well, maybe I don't. Hold on, let me think. Line, I'm trying to rotate and orbit. So if this is my wall here on the right side, I come straight through. I don't know if I like that. Need more material on the tab around the screw? I don't know, you think? Why though? Because the screw's just going to compress those two together as I drive the screw through here. And I might even want to, I could use the hole tool and put a hole in it, but I might actually just want to drill a hole. I'm going to throw a number 8 screw. You can just use a 1/4 inch drill bit, and then I can line it up there and kind of put the screw wherever I want to put it. And I probably should fillet this for some strength here on this edge, if that's what you're talking about. I guess I can do that. So these two need a face fillet. Nope. Like that. So it just puts a little curve into it. It's just going to add a little bit of strength to that corner. Should be fine, and I could probably do it here as well. Oh, fillet. Oh, fillet. Just a little added strength there. Yeah, dude. Paige is saying night night, dude. Check out the vid in the vault. Yeah, I'll probably post this one on YouTube too. I gotta get some more content up on the YouTube channel on the YT. So what do we think? If we put a hole right through here, I'm not even sure I even need to put a hole through there. See what it would look like. Why not? I feel like I'm pretty close to at least getting a prototype. What do you do for a hole on this? You just plop a point in and dimension it. So the distance from here to here would be let's put a and then I forget how far we've made it out. Oh, that was an awkward curve there for a second. See that? That was really weird. So that's the center, and I just knew that because that's how I designed it to be. So then, excuse me, I kind of have the hiccups, guys. So hole tool, let's see, I want to do a hole through. See, maybe I want that higher because it is going to be a little bit lower on the other side. Do those angles. So let's go ahead and fix that before we make this hole. Let's pop open the sketch, flip around to the front. Let's make it 0.3. Let's just bring it up a little bit, just so the tab doesn't break off the strap. Yeah, are you talking about here, AK? I think that should be okay. I mean, I could kind of clear this off, but that fillet should actually handle that pretty well. Fillets are pretty strong. Because really, I just needed to hold it in place. Yes, I don't know if I want to countersink that hole or not. Because I was thinking I just run. The problem is it's so deep. It's half inch. I know my screws are only half inch, so I'm not even into the wood yet. So I have to get a special screw for that, which I didn't want to do. But I probably have small. Man, I probably have some panhead screws I could do. Because see, if I countersink it, it's not going to get as much pressure. I want something that's going to be flat instead of having that 70, what is it, 82? That 82 degree angle that you have on a countersink. So I think I might want to counter bore it. So if we think, I can probably show you guys the difference between the holes. Okay, so that's a counter bored hole. So like that, the screw actually seats in there, so it's flush. So like you can basically like rub your hand across the front of this, and you wouldn't feel the screw because it would sit down in here, and actually the screw would push on that section. But I don't really see a purpose here because like you're not going to rub your finger on it. So I actually don't even think counter. I'm probably just going to go to a simple hole. Let's go show you a countersink though. So a countersink hole is going to have that tapered angle. It's an 82 degree angle because that's the standard for a screw. So, but I'm going to go for just a simple screw. My hole type is definitely a clearance hole. I don't need it to be tapped, which would be like threaded. So we'll just have a clearance hole. Size 8 is going to work just fine. Screw, that's like 8 is probably a pretty standard size screw hole, if I'm being honest. Like if you go to the store, 8 is going to be a one you see all the time. And a free fit, that's, I don't know what close and free are. I mean, I know the ASME standard, so maybe I should go for loose, but free's fine. Because again, I don't need this to be that tight. Because really, what's going to happen is it's the pressure when it reaches the wood on the other side and pulls it in, that should clamp this down and make sure it's real tight. Now the only issue is I wonder if I made this too tight here. I didn't make it parametrically, so that could be a pain in the butt. But yeah, so let's pop that hole in. It should print just fine. I don't see any issues there. So let's do it. Let's print this prototype and see what happens. AK, you see anything there that you like or don't like? Wrap it around that. I feel like that'll do its job. The only thing I'm wondering, I wonder if I made it a little tight. So actually, I could give it a little play if I actually got rid of this fillet. That would give me a little bit more play. So I'm going to go ahead and do that just to be on the safe side. So that was all the way back in sketch 1. So this fillet, we're just going to turn it, go hover, drag until it's perpendicular. Just going to mess up the whole thing. Oh no! All right, plan B. Plan B, we'll just go do After the Fact. Sketch on the top, and I will just find that intersection, draw a line out, 3-point arc. Actually, you can just use, where's the use button? Use that curve. So now it just traced that curve. I use the use button all the time. So then now I should be able to extrude that section, remove the material. There we go. That should be a little bit better. Just over-engineer the crap out of it, eh? Okay. I mean, yeah, right. That's kind of the plan. I think that's gonna work. I don't want to over complicate it. I want to stay with simple. And I'm printing ABS without an enclosure, which on the Ender 3, well, anybody says you can't do ABS without an enclosure, but I just did this one, and it's about the same height. Actually, I think this thing was, it's not the same height because this one's 3/4 of an inch. So this is 0.45, and it did just fine from an ABS standpoint. You need a mod? I do. I just don't. I haven't looked enough into the mods yet. But yeah, I was thinking. I mean, Patriots fans here all the time. Um, you're here quite often. Campbellman is hit or miss. He's streaky. So I probably need to get some. Mods for the chat instead of it just instead of me just holding messages. Let's do it. So, all right, so from here on Onshape to get it to 3D print is you go down here where it says parts, which I think this is weird because you got to be careful on your extrusions. Like, let me show you what I'm talking about. An extrusion 3, new is an option, and you don't want to create that as new because if you make that a new, it actually creates a second part. So it's almost like you're creating multiple parts in one. And I chose add every time because I just wanted to continue to add material over and over and over again. So it was all one part. So now I have just one part. I can name it if I wanted to, but I'm just going to go to export, and we're going to just name it the same exact thing. I don't know why it doesn't auto-populate this. Again, I've barely been using this. What did I just type in? Strap. STL is your stereolithographic format for 3D printing. I'm going to go in millimeter. Fine resolution is great, and download. There it is. All right, so I'm going to use Cura. I haven't updated it, so let it load up, and I'll share that screen with you guys as it loads up. I don't know why this program takes a load. It doesn't even seem like it's that beefy. But Cura is, I don't know, I feel like it's the most popular one. Like if you go to any of the 3D printing subreddits or things like that, pretty much everybody's using Cura. Not that it's the best one, it's just the one that everybody uses for whatever reason. I don't know. So here, let me share that screen. It just loaded up. Cool. All right, so this is Cura. Says I got an update available. Great, I'll do that later. So let me just pop in that gutter strap. There it is. All right, so I'm printing on my Ender 3. I've got a couple different profiles. I have two Ender 3s, one with the glass bed. I'm actually going to print this on the one that does not have the glass bed, so that's the regular one. And I'm printing on ABS. So I just did a print on ABS, so I'm actually not going to tweak any of the settings at all. I'm literally going to leave it as is. I'm kind of moving off to the side here on my 3D printer to get ready. So I do not have my printers directly USB'd into the computer. So I just take a micro SD card and an adapter. And the micro SD card plugs directly into the 3D printer. And you can hear the noise. That is the adapter going in. All right, so I'm going to print, again, the quality here doesn't really matter. I'm using a 0.4 nozzle. 0.28 makes me a little bit nervous, so I'm going to go 0.2. I could probably print it at 0.28 thickness per pass, but 0.2 is fine, or per layer. 0.2 is going to be just fine. Probably won't change that much print time anyway. I do want this thing to be 100% solid, so that's what this is going to do. Actually, do I even need it solid? It's so thin, I might as well. Here, we can play around with the times. But I'm not going to do any supports or adhesion. I just want to print it directly as it is. I shouldn't have any issues with that. I don't have any awkward angles or anything here. Yeah, that should be good. I literally don't see a problem here. Got a flat surface to start on. I think this is going to be good, a good print. So okay, so supports, adhesions. Some people like adhesions for beds and things. I really don't. Sometimes I put a little brim on it, but definitely not a raft. A brim is like a brim of a hat. All right, so let me show you what I'm going to print at. So I'm using Hatchbox ABS, and you're supposed to have an enclosure around your 3D printer to help with the dissipation of the heat, because if it cools too fast, it'll crack. But I'm going to print this thing pretty hot. So I'm going to go 90 degrees Celsius for my bed temperature, which is pushing the limits of what my printer will handle. And then I'm going to go 240 on the nozzle. And this is all Celsius, so this sucker's going to be hot. I have tried some other slicing programs. Most of them are some sort of Cura mods anyway. but so like I use Dremels a couple times. I've used Octoprint, no Astroprint, which is cloud based. But again, they're all Cura clones. So like, and Cura's free, so that's the one I'm most familiar with. And once you get like used to like all the customization you can do, you can really troubleshoot to your specific printer. My actually favorite thing is this experimental button here. There's some really cool stuff. So like tree support is one I've turned on. So I hit this gear, it can like you can show all the different experimental things you can kind of play around with. There's some really cool stuff that they're playing around with that's still an experimental. But tree support is a really cool type of supports that I've used. Instead of building like linear arrays, it like builds this like tree support, and it just snaps off really easy. I've had really good luck with tree supports instead of regular supports. So I actually turn off my regular supports and turn on trees. So that's pretty cool. But yeah, I've had really good luck with Cura. Um, my print speed though, my Ender 3s, I know they can go faster than 50, but I am going to slow it down because I'm going to let this thing print. I don't need it until tomorrow. Yeah, Dremel's one. I so there's two that Dremel uses. There's a cloud-based one, and then I actually don't even think I have it on this computer. So the cloud-based Dremel software I cannot stand. I just think it was awful in every like any type of deviation from the norm. It just doesn't want you to do, and I feel like the supports are too difficult to remove. There's little spacings between the supports I don't do well. Um, but there is a Dremel one that maybe it's not Dremel. I know Dremel worked. I think it was like a combination of Dremel working together with. It was called Print Studio. I'm trying to think who it was. It might actually have been through Autodesk. It was. It was an Autodesk. So Autodesk had a slicing software called Print Studio, and I think they collabed with Dremel on it because there were some similarities. But that one was so much better. I felt like, but they discontinued it. I found an old download of it from like an old CNET site or something like that. But that was a couple years ago now. But that one was really good. But I know it's totally not supported now. And it was one of the things like once I jumped over into Cura, it was it was kind of like okay, once I got it figured out and figure out how you can customize and saving all your printing profiles and things like that, it was kind of like okay, maybe this is probably there's a reason why so many people use Cura. All right, so I'm gonna go down here, click slice. Should tell me time. Okay, see that's not bad. 3 hours, 18 grams of filament. That's not bad. Can handle that. So let's just, I did want to check the infill patterns here just to see what would change if I dumped this down like 20% infill. So as you can see that even the icon changes from solid. I'm just curious how much time it actually saves. Okay, barely any time at all. 2 hours and 40 minutes if I make it hollow on the inside versus 257. I'll take the 17 extra minutes and make this thing 100% solid. And again, the reason I'm going to use ABS is because this is for an outdoor application, as you guys can see in the picture below. It's going outside. I'm making a custom deck modification for a guttering system for underneath the deck. If you watch the beginning of stream, I kind of explain what I'm doing there. But yeah, so this is I'm gonna give it a shot, dude. AK, dude, it's so much fun, dude. I totally recommend. I actually had one of my regular viewers just get into it. He actually ended up buying the same printer that I've been using, and he's having a blast with it. He pops in. So I'm surprised he's not here today. I'm sure I'll watch it on VOD because he's been begging for some modeling lessons and stuff like that. But so yeah, it's a really cool. I mean, I guess it's called a hobby. I probably use it more for like part manufacturing and jigs and things like that. Like I coach, so like I play a lot of sports too. So like I'm like, you know what? I'm tired of buying whistles, so I made a whistle, and I made a dozen whistles because I always feel like I'm as a coach running. I'm like, oh, where's my whistle? So now I can just keep like a dozen in my car, and they cost me nothing, and it was fun to make. Um, but like little, I mean, just like little jigs and stuff that used to help me make projects like woodworking. So like yeah, so welding is something that's really cool. You can make a ton of money with it. For me, like I don't know, it doesn't intrigue me as much. I don't know why, but woodworking totally does. I picked up my shop certification last year, and I'm going to be trying pretty hard this next year to transition from a engineering teacher to a woodworking shop teacher. So that's going to be one of my life goals here in the next 12 months. So stay tuned to see. I'm actually hopefully I got a lead on a job. I don't want to put all my eggs in one basket, but I got a really good lead on that upcoming. So um, could be a whole lot more woodworking than what I'm already doing, but I do a ton of woodworking as is. So AK, that woodworking's a ton of fun, but making like jigs and stuff to help you with, like, oh my gosh, that's what I use most of my 3D printing stuff for, is little parts to help out with that. So all right, so I'm going to go ahead and save this to the removable drive. I'm going to redirect some of my lighting here so you guys can get a better view of the printers. Let's get some light there. All right, I'm rolling around on my rolly chair here. Yeah, exactly. That's the whole point. It's like, plus as a math engineer guy, I feel like there's a lot I can bring to the shop from a math standpoint as well. But yeah, dude, integrating the 3D printing and getting to know like what type of filaments you need, and for indoor applications, outdoor applications, things like that. Oh, you probably could. I mean, there's no reason you can't put. I mean, 3D printing is like your plastics, right? Although you can 3D print metal now. 3D print concrete, metal. There's all sorts of stuff. All right, I'm gonna move the camera, so this is gonna get a little crazy for a second. Ooh, you know what? I probably have to disconnect the video cam and broadcast via Wi-Fi. So we might lose a feed here for just a second. Stop video feed. I'm still here, guys. I promise. All right, let's go through Wi-Fi. We're trying again. If this doesn't work, let's back in. It says I'm on the same Wi-Fi. Oh, let's try this again. Boot up. We're on Wi-Fi. Oh, I'm on the wrong port. Let's try that port. Hey, all right, we back. All right, cool. All right, so let's come over here. Do some 3D print. So yeah, you can see all my mess of um, whistles and straps and all sorts of stuff that I just play around with. Anyway, let's kill this down in my Leicester City logo. So here's one of my 3D printers. The other one is right there. It's out of service. I got to do some repairs on it, but it's all good. All right, so we're back here. So SD card goes here. Again, this is Ender 3. My bed's a little messy here, but it's level. That's all that really matters. It's off right now, so everything free moves. So I'm going to peel off a little bit of the print. Actually, I probably don't have to do this, but a little maintenance never hurt nobody. All right, so pop that off. All right, switches on the back here, so let's turn this on. And I've actually 3D printed a lot of parts for the printer as well. What have I done on this one? Actually, I haven't done too much on this. Actually, yeah. So I've 3D printed this little box, this little tray. There's actually some green clips in there to clip some of the wires back. And actually, the circuit board here didn't come with a back, so I 3D printed a back for it. You can see it's like a different color. It's kind of whitish. All right, so pretty simple. I've got the filament already loaded in there. It just sits up top in a spool. It's white ABS. All right, so to the screen. So as I click the button, that's like the confirm. It should be touchscreen. How old is this screen though, right? Did I feel like I'm on like a 1995 computer? Maybe even older than that. Yeah, Windows 95 was better. This is like a DOS system. It's like early 90s, late 80s. Anyway, I'm gonna go to print from. I don't know what TF stands for, but there it is. That's my gutter strap, and it should be pretty simple. Click. So it's going to heat up the bed to 90 degrees, as you can see there. And then once that gets to 90, this nozzle temperature, currently it's at 90 degrees Celsius, is going to go up to 240. And once it does that, she'll print. And like I said, it's going to take 3 hours, as we said.